Hello everyone, I am going to explain question number 22 and question number 23 of exercise 2.1 of class 12. As you can see the question on the screen, the question number 22 is we have to solve for x. The equation is available to us. Now we will start by the equation. Here the equation is 3 tan inverse and then some values are given to us. In the same way, tan inverse 1 upon x is equal to tan inverse 1 upon 3. Now just we will observe carefully all the terms. When we will observe it, we will find out that since because of this 3 here, we can't use the formula here. That's why first we will try to remove the 3 from here. Before that, we will simplify it because this 1 upon 2 plus root 3, it's an irrational number. So we will rationalize and we will try to simplify it. That's why in next step, what I have done is, I wrote this 3 tan inverse as it is and I rationalized the denominator so that I can simplify it, and the remaining terms I wrote as it is, and after rationalization we found it. Here in denominator I use a plus b minus b formula, that is a square minus b square, and remaining terms I wrote as it is. Now when we will solve this, we will get here 4 minus 3, that is 1. So from denominator is only 1. So we simplified it as 2 minus root 3, and the other terms I wrote as it is. But further, when we will observe carefully, we can't use the formula here. That's why we will try to remove this 3, and along that since we can't use the formula, so I shifted this minus tan inverse 1 upon x in other side so that here we can use the formula in next step. Now you know that 3 tan inverse theta formula is here, tan inverse will come. So I wrote here the answer for this formula is tan inverse 3 theta minus theta cube upon 1 minus 3 theta square. So this complete is our theta. So 3 theta, here 3 theta is there, that's why 3 multiplied by this theta, then minus theta cube, that's why minus theta cube, and then 1 minus 3 theta square. So 1 minus 3 is complete is our theta, so theta square. Students, apply here bracket. I just forgot. More better that you should apply here bracket. Now next step, here in this right hand side, just see the terms are in the form of tan inverse x plus tan inverse y. Now you know tan inverse x plus tan inverse y formula is tan inverse x plus y upon 1 minus xy. So tan inverse, what we have here, x plus y. So this complete is our x and this complete is our y. So tan inverse x plus y upon 1 minus xy. So we use the formula, this formula in these two terms in the right hand side, and in left hand side first we will solve these brackets. To solve the bracket, here I open the bracket. So I got here 6 minus 3 root 3, and here we have to use the formula a minus b whole cube. The formula a minus b whole cube is a cube minus b cube minus 3ab bracket a minus b. Since a cube minus b cube, so what is a here? 2, and what is b here? Root 3. So a cube minus b cube, then minus 3 into a into b, then bracket a minus b. So like this I opened this bracket which is in the form of a minus b whole cube, and in denominator I wrote this 1 as it is and this 3 also as it is, and this bracket I use the formula a minus b whole square. So I got these terms. Now just see the next step. In next step, here you just see, here also tan inverse and here also tan inverse. So they will remove each other. We are remained with only the polynomials here. Now in this side, we are these two terms will write down as it is because we can't add subtract. Now here 2 cube is 8, then root 3 cube is 3 root 3. We will multiply them. This bracket I wrote as it is, and here also I have done the square and multiplied it. So I got this bracket. Now in this side, what I had done is I took the LCM of 3 and x, and here also I took the LCM of denominator. So in numerator also LCM came as 3x, and here also LCM came as 3x. Now in this fraction, when we will observe properly, just see here also 3x and here also 3x, so they will cancel. So we are remain with only x plus 3 and denominator 3x minus 1. Now here after this what I had done is I multiplied it and then I opened with minus sign also. So carefully you have to take care of the sign and open the brackets. So I got this in denominator also. 4 plus 3 is 7, 7 3s are 21, and then minus into minus plus 3 4s are 12. Like this we simply basic concepts we had used and we had opened all the brackets. Now what we, after all the brackets removal, what we obtained is, here just see it's minus 3 root 3 and here we have plus 3 root 3, so they will remove each other and then we remain with only 12 root 3, that is we wrote here as it is. Then 6 minus 8 and minus 18 will give us answer minus 20, and down also 21 and 1 will give us minus 20, and this I wrote as it is. Now by this way what we found is both the terms are same, so they will cancel each other, so here only 1 remains. Now it's in division, since it's in division, so it will go here, we multiply by 1 and we will get here 3x minus 1 and x plus 3. Since we are solving for x, so all the x will separate in one side and all the constants will separate in other side. 3x minus x is 2x and here we will get 4. Now again 2 is in multiply, so it will go in divide, and after all division we got answer 2. So the solution for given equation is 2. So once briefly just understand how we had done it. First we had rationalized this fraction. Because of rationalization, simply we got here 2 minus root 3, use here bracket, I forgot. Then use 3 tan inverse theta formula. It's very important formula and very important step for this question. Because of this 3 we are not able to use any, means we can't remove tan inverse from both the sides. So first we should remove this 3 by using this formula, and in this term use the formula, and while in other side shift this minus tan inverse x in other side and use the formula of tan inverse x and y, and then simply after removing 10 from both the sides, simple open the brackets and simplification just do. That will give you the answer x is equal to 2. And now we'll move to the next question of same exercise. Next question is 23 and again we have to solve for x. Now here the question is like this, how many brackets we have here. First we will start from the smallest bracket, that is innermost bracket, that is 2 tan inverse x, and we will see what we have outside. Outside we have cot, so we should try to convert it also in form of cot. So better to convert first in tan, then we will convert it to the cot. Now what we have here, 2 tan inverse x, and you know the formula of 2 tan inverse x is tan inverse 2x upon 1 minus x square. So in this innermost bracket use the formula, and other term, that is this cot just write as it is, cos inverse write as it is, and sin 2 just write as it is with their own brackets properly and equal to 0. So in the first step what we had done, we had used the formula of 2 tan inverse x only. Now here is cot but here is tan, so we should convert it in cot inverse. So you know tan inverse x is cot inverse 1 upon x. So here just write down cot inverse and do the reciprocal, because since x is there here, so we have done its reciprocal. That's why to convert tan in cot, do the reciprocal of the fraction, that will give you 1 minus x square upon 2x. Now cot and cot inverse will remove each other, so we are remain with only this. So in next step, sin 2 just write down as it is, cos inverse write down as it is, but cot and cot removed. Now what is remained with? Only 1 minus x square upon 2x. So write this here as it is. Then all means this big bracket, this curly bracket and small bracket will remove. Only big bracket is there, so write down big bracket and equal to 0. Now in next step, here we have cos inverse, but outside what we have? Sin. So conclusion is cos inverse we have to bring in the form of sin. That's why we had used this formula, cos inverse x is equal to sin inverse root 1 minus x square. So what is x here? This complete polynomial is x for us. So cos inverse, this complete is x for us. So cos inverse x is equal to sin inverse 1 minus x square. So I wrote here. Now what we had done in this step, we converted the cos in the form of sine inverse because outside sine inverse we have. Now here simplify it, open the bracket. So you have to do square in both numerator as well as denominator and then take the LCM. When you will open it, use the formula a plus a minus b whole square, and when you will take the LCM, here 4x square will come. Now this 2 just shift inside because it's in multiplication, so you can shift this 2 inside, write 2 here, and then take the, I took here LCM, I open the bracket, and after this 4x square plus 2x square will give you 6x square, and these terms I wrote as it is. Now what we have, just see, sine, then 2 sine inverse. So you can't cancel them. You means they can't remove each other because of this 2. So conclusion is 2 sine inverse theta formula we have to use, and you know that 2 sine inverse x formula is sine inverse 2x root 1 minus x square. So this complete is our x. It's very huge, but this complete is our x. And what we have here, 2x. That's why first I wrote here sine inverse, because 2 sine inverse formula starts by sine inverse. So write here sine inverse. Then what we have here, 2x. So 2, then this complete is our x. So 2x, then root 1 minus x square. So root 1 minus, this complete is our x. So complete I wrote here and then square. So we use the formula 2 sine inverse x is equal to sine inverse 2x root 1 minus x square. Now we will simplify it, and you can see since there is no 2 now, so sine and sine will remove each other. So I removed here and we remained with only these two sides. Now here this just write down as it is. I separated the root to numerator as well as to the denominator. Here also when you will do the square, this root will remove by the square and we will get only this fraction, and since 1 and minus is there, so just take the LCM. That will give you this step, and this root is outside root. I hope this step is clear. And further, since I separated the root to numerator denominator, so denominator LCM's root is going to be root 4x square. And once again I want to explain this. Here root square, when we do, root and square will cancel each other. Then I took the LCM, so here 4x square and denominator will got this. And since this root is again remained here, so I separated the root to the numerator as well as to the denominator. I hope this step is clear to you. Now since equal to 0 is there, so denominator is in division, so it will go in multiplication with 0, so it will remove. So I shifted this here and it got cancelled. In the same way 2 also shift here, 2 is in multiply, so when it will come in the right hand side, it will divide by 0 and will remove. So conclusion is, from this step to this step, remove this 2, this denominator, give it to the 0, and it will multiply by 0 and divide by 0 and becomes 0 again. Now here this root and these 3 terms I wrote as it is because these all are different, we can't do anything. And here I open the bracket, and that gave me x square plus 1 and minus, because we can separate them. Now these two roots product is 0, so either this is 0 or this is 0. Now if when we will assume this first root as 0, it will give us this. Now on squaring both the sides, root will remove, and it's a quadratic. We will convert it to the quadratic equation in form of x square, and I use the quadratic formula. Quadratic formula is x is equal to minus b plus minus root b square minus 4ac upon 2a. That formula we will use here. So here we are going to find out x square value, and my a is 1, b is minus 6 and c is 1. So I use the quadratic formula here. Why here x square came? Because we can write it as x square to the power square. So in the formula x, instead of x, here for us x square will come. That's why we are calculating the value of x square. So here what we have, minus b, and what is b for us? Minus 6. So minus and minus will multiply and become plus 6. Then plus minus b square means 6 square will give you 36. Then 4 into a into c. So 4 into a is 1, c is also 1. So 4 into 1 is 4. So I hope this formula is clear to you. And in down we have 2a, and what is a here? 1. So 2 into 1 is 2. Now we have to simplify this. 36 minus 4 is 32, and 32 we can write as 16 into 2, and 16's root is 4. So like this 4 came outside. Now this 2 just will divide by both 6 and 4, because this 2 is for both 6 as well as 4. So we cancel it. We got here 3 plus minus 2 root x. But since we have to solve for x, we don't want x square, we want only x. So further we will solve it. What we have done is 3 we wrote here as 1 plus 2. Now this 1 we can write as 1 square, this 2 we can write as root 2 square, then plus minus, and this we can write as 2 into root 2 into 1, because it remains same, 2 into root 2. So what we are trying to do is, we are trying to convert this 3 plus minus 2 root 2 in the form of a square plus b square plus minus 2ab, so that we can write as it as a plus b plus minus b whole square, so that square and square remove each other and we can get the answer of x only. So this step is very important, students. We want only x from here, so we try to convert these terms in the form of a square plus b square plus minus 2ab. So it gave us the answer a plus minus b whole square. I hope this step is clear to you. Now when we take the square root, square will remove. Since we are taking the square root, so this bracket will acquire both the symbol plus as well as minus. So that is the value of x when we assumed the first root as, that is first root as 0. Now we will move to the second root. Then if it is 0, then what we will get? We will see in the case second. When we assume that when it is the root x4 minus 2x square plus 1 is 0, simply just do the square in both the sides, root will remove. Then do the square here like this. Means this is a square, and write down here 1 square. So it will convert in the form of a square plus b square minus 2ab, that is a minus b whole square. Take the square root in both the sides, that will give you x square minus 1 equal to 0. And this is in my negative symbol, shift here positive, and then take square root again. So when you will take the square root, you will get plus minus 1. So from case second we got the value of x as plus minus 1, and from case first we got the value of x as plus minus bracket 1 plus minus root 2. So write down the answer. So this question is lengthy but easy to solve. So here once in briefly I just want to explain to you. What we have done is, we converted this to tan inverse in the form of tan, and tan to the cot. So cot is removed by cot. Then convert the cos in the form of sine, because sine is outside. Then shift this 2 inside. Use 2 sine square theta formula, so that it will come in the form of sine. Now sine and sine just remove, and then simplify this step. And after that assume this as 0 first, and then assume this as 0. That will give you the values of x. And the values of x are plus minus 1 and this. Thank you.